Welcome to Stelligent's DevOps on AWS Radio with your hosts, Duvall and Brian Jakovich.
Welcome to our 19th episode of DevOps on AWS Radio. I'm Paul Duvall, CTO at Stelligent, and I'm joined by my co-host, Brian Jakovich, who is a director at Stelligent. You can check out our previous episodes by searching on DevOps on AWS Radio and by going to Stelligent's blog. We're looking for engineers who are passionate, consultants as well, who are passionate about continuous integration, continuous delivery, DevOps on the AWS platform. In this episode, we're going to be discussing recent news in the DevOps and AWS world. We're also having a discussion with consultant Paul Julius, who's the founder of Willow Bark Consulting. So let's get into some DevOps on AWS news. So Stelligent Mu, which is a open source DevOps on AWS framework, just released its latest version, which is 1.5.4. We're providing support for the new SSM Session Manager. We're providing support for SSM inventory on ECS container instances, support for Aurora Serverless, and then also for stack policies to protect RDS and KMS resources. Next announcement is that AWS Config has added support for code pipeline. And so this is a really interesting one. With config adding support for code pipeline, you can enforce and react to any change within minutes of a pipeline update to ensure conformity to whatever rules you end up designing. So for example, let's say you have standards for your testing and for your environments, or maybe automatically disabling transitions and checking roles and permissions, just to name a few. So far, at least I haven't found a ton of documentation on this, and I haven't tried it out myself, but it's going to be, I'm going to be looking into it in the next few days or so, and hopefully be able to get a blog out that talks about this. So AWS has announced Cloudformation Macros, and so you can use macros to create your own custom transforms. So for example, you can create common string functions for templates or define shorthand syntaxes for common Cloudformation resources. And what this does is it provides you extensibility, so you don't have to use just the built-in Cloudformation resources. You can start to extend that using the Cloudformation macro and using the Cloudformation language itself. AWS Config has announced new managed roles. If you're a listener of the podcast for a while, you know we're big on AWS Config and config rules, and so they've announced 7 new managed config rules. So a couple examples. One is that you can verify that Amazon Guard Duty is enabled or centralized in the AWS account using the Guard Duty enabled centralized rule. Another one is that you can check if Amazon RDS snapshots are public using RDS snapshots public prohibited. And so there's 5 others, but these are managed rules, which means it's built into AWS Config. Of course, you can also write your own custom config rules as well and include that in your AWS account, looking for, and these are some of the built-in as well, but you can extend some of the capabilities, such as ensuring that all your IAM users use MFA and things like that. AWS Code Build has added the ability to create build projects with multiple input sources and output artifacts. And so your projects can now use one or more sources from Amazon S3, Code Commit, GitHub, GitHub Enterprise, or Bitbucket. You can also upload multiple sets of artifacts to one or more Amazon S3 buckets. And you can configure your project to have no input source at all. And you can now use AWS Code Pipeline integration with Code Build to create a pipeline with these multiple input and output artifacts to a Code Build project. So I'm actually curious whether or not we're going to see this same functionality in Code Pipeline as well.
Okay, well, thanks, Paul. So I have 2 things that I want to go over. The first being AWS X-Ray now supports Amazon API Gateway and new sampling rules API. So the support for Amazon API Gateway just makes it easier to trace and analyze your requests through X-Ray. It's X-Ray's just adding more support for the other AWS services. And then the sampling rules allow you to customize the requests and traces that you want to record. So this is more on the developer side of the AWS services, but it's a new addition. And then the other one is Hello Retail. This is a blog post made by a cloud guru that goes over how Nordstrom uses serverless, so AWS Lambda and API Gateway and a variety of other AWS services to build an application called Hello Retail. And it talks a lot about it. So it's one building a walkthrough of how to build this application and the variety of serverless resources, but also how everything works together. For instance, why you would use AWS Kinesis versus AWS SQS and the variety of different reasons that one is more valuable than the other. But at the end of it, you'll have a fully functioning serverless application, and I thought it to be really interesting and informative of how to build these applications.
So next up, I speak with Paul Julius, who's an independent consultant that founded Willow Bar Consulting. He's based in South Dakota, but travels extensively. This is one of my longer conversations, and we get into a lot of history and developer practices. I've known PJ since 2005. He's the co-founder of Cruise Control, the open source continuous integration framework and tool. He's also worked at Stelligent as an employee, and he's worked with us on several engagements over the years. He starts out describing his background in philosophy and computer science and how that's come into play in his work. So he goes into a bit of the history of continuous integration and his involvement and others, and including some of the backlash on the tooling and really how it's more about focusing on increasing the frequency of integrations between developers, meaning that's the point. We talk about Git Flow and some patterns that can work more effectively to increase the frequency of integrations, including branch by abstraction, feature flags, pairing, and even something known as mob programming. And finally, PJ is the co-founder of the Continuous Integration Conference, which is known as KitCon, CITCON. It's a worldwide open spaces conference. I've been to several of these, talk about continuous integration testing, continuous delivery, DevOps, really ultimately good developer practices around software delivery. And this occurs 3 to 4 times a year in 4 continents. And so this is a fun one. As I mentioned, I've known PJ for years. And he definitely shares just a lot of great tips in this one. So PJ, why don't you start off and share a little bit about your background and your interests for our audience?
You bet. So at university, I studied philosophy and computer science, and I actually spent more time taking philosophy than I did computer science, but ended up doing both and had a strong passion for both. At the time, I was working at a company that was originally called Gateway 2000 and then became Gateway. It was a computer manufacturer and got really interested in all of what was happening with the way that computers and software were advancing at the time. And from there, went into becoming the IT manager for a small nonprofit company here in Sioux City, Iowa, where I grew up. And loved doing that, loved working with people and loved working with the clients so that they were serving and automating all of these different paper-driven processes that this nonprofit was using to provide services to people, and spent a lot of my time taking paper forms and turning them into automated database-driven workflows. Knowing that I really wanted to get into Java development and enterprise development, I went from there and took a position with ThoughtWorks, which at the time was about a 200-person consulting firm, but they were getting ready to go into this next wave of their growth around Java and enterprise development. And I spent, I think, 8 years working with ThoughtWorks on a variety of different projects and helping to lead projects and grow projects that were really trying to transform the way that the clients were doing software development within their organizations. That was around the same time that Agile became a phenomenon, Agile software development. So I was fortunate enough to be in on the ground floor of that. Everything everything related to test-driven development and pair programming, and of course continuous integration, which is what I became known for. I being, the type of lazy software developer that I am, I wanted to automate away anything that seemed repetitive or boring to me. I wanted to take, this process that we had to go through to build software and deploy software. I wanted to take that and automate it so that I could focus on the interesting creative bits. And that's where the whole continuous integration thing came from. And I got together with a couple other guys at ThoughtWorks, and we created Cruise Control, which was the first open source continuous integration platform that really took off. It changed the way that all the projects that I was working with, other projects at ThoughtWorks, and then other projects around the world started thinking about what was important for us to do within a software delivery project. In 2005, I think it was, that's when I ran into you, Paul Duvall. I think that you had been working on your book about continuous integration, and Martin Fowler introduced me to you, and I got the opportunity to take a early look at what you were writing. I was really excited about it and happy that somebody was taking this and turning it into a book that everybody could enjoy. And then right around that same time, I remember, I think in one of our early conversations, I invited you to this little get together that I was going to have with another continuous integration compatriot of ours, Jeffrey Frederick. We were going to have a get together in Chicago that we were calling KitCon, the Continuous Integration and Testing Conference.
That's right.
Yeah, and that's where you and I first met in person. But that conference we really got people together from what at the time were these different disciplines, these disparate disciplines of the coding side of things and the testing side of things. And what we were trying to say with that conference was, look, we should all be working together to do this. These things go hand in hand, and we shouldn't be writing code for some period of time and then testing code at some later time. We should be doing that as part of the continuous integration process that we run constantly. From there, KitCon has gone on now for 13 years, and now we do it around the world. And it's continued to be this place where we can bring people together from different sub-disciplines within software development to talk about how to deliver better software, how to make it easier for everyone working on the process of software delivery. So program managers, project managers, of course, testers and testers of all kinds, both people that fall into the quality assurance, QA realm, people doing automated testing, people doing unit testing, and then developers of all sorts, everybody from back-end developers, front-end developers. Now we've got serverless, people writing serverless code, those of us automating a lot of the infrastructure, which of course you and I do a lot of, Paul, now with cloud around AWS. And that's become a lot of what excites me, is getting people together to talk about and share ideas in an almost open source like manner, sharing ideas that aren't proprietary to any particular company that they might work for, sharing those ideas with each other to help improve the overall state of the art with regard to software development. And that's been a huge driving force for me. And I think that's played into a lot of what I've done professionally with, of course, consulting project after consulting project after consulting project. And then I did end up taking a full-time position at a company named Intent Media in New York, and I was the chief technical officer there. Through that position, I was able to focus even more so on how do we take these different steps that we have to do in the software delivery lifecycle and take the ones that are boring and maybe automate them or make them somehow interesting, because it seemed to me at the time that one of the things that that was really hurting us as an industry is this sort of constant turnover we have. I think I've heard numbers like out in the Silicon Valley, it's typical for people to only stay with a company for maybe 12 months or at most 18 months. And I think that part of the reason that people are doing that is because it's boring. It becomes boring after a while, it becomes rather mundane after a while to keep doing the same things over and over again. And of course, it's part of their resume building cycle. My hypothesis was that if we can keep our employees engaged, if we can keep them excited about the work that they're doing, if we can be trying to present them with new ways of doing things, that they will continue to be fulfilled within the company that they're in, and that actually has a huge cost benefit to us as a company. So I explored that a lot as the CTO and feel like we had some great success. We went from an 18-month or 16-month turnover to over 3 years. And that was a huge benefit, and it was a really interesting experiment for me. And then now I'm back to running my consulting firm and doing consulting work again, working with different clients on a variety of different subjects, everything from build and deliver software. Of course, that's been something that I've been known for coming up on 20 years now. But also, how do we support this software once it's in production? How do we keep this software running? What do we do when the pager goes off? Who should answer the pager when it goes off? How do we convert from having a DevOps team or a unit to having a DevOps philosophy? How do we take all these really interesting opportunities that we can now tap into from the cloud platforms like AWS and turn those into interesting ways for us to move faster, deliver faster, create more interesting software? So that's what I'm up to today.
That's quite the introduction. Thanks for sharing. Now, actually, I have a few follow-up questions for you. So you mentioned that you had created cruise control. I think it was along with, was it Paul Heyman? Is that right?
It was Alden Almagro was the other co-founder.
Yeah, and you were mentioning that continuous integration took off from there, and basically through the release of a tool, this open source tool with cruise control, and that's how I think I was introduced to continuous integration, is learning about cruise control, probably 2003 or something like that, 2002 time frame. But it's interesting. I remember at the very first KitCon, there were 30, 40 people there, and James Shore got up and talked about the rubber chicken, right? Basically, his argument was you don't need a continuous integration server. But it's interesting to say that the wider software community learned about continuous integration through cruise control at the time. And so maybe if you can just talk a little bit about that idea that he shared in terms of not needing a CI server, but then also to kind of juxtapose that to the idea that that's what made continuous integration a popular practice that people started to use, is the fact that a tool came out. At least that's my position.
Yeah, it is really interesting, so cruise control came out in 2001, and then James Shore started talking about his rubber chicken, doing a continuous integration on $1 a day with a rubber chicken and a bell, and that was in 2005, 2006. So over that 4-year time span, we already get this backlash against this automated tool. And I think that James Shore had a really, really good point. We still see this today. So this is still a salient point today. And the point is that just because you set up a continuous integration tool, a continuous integration server, just because you are running some sort of automated process frequently or on every check-in, doesn't mean you're doing continuous integration. Continuous integration really was, the term was introduced from the original extreme programming the Extreme Programming White Book. And in that book, what they talk about is continuous integration being this practice of, once they were done doing their coding work, what they would do is they would get up from the machine that they had been working on, and they would go to a clean environment, a separate machine that was sitting in the team area, and they would pull their code over to that machine and run it and execute it in this clean environment and make sure that everything worked on the clean machine, everything worked with everybody else's code, and if it did, then they were happy, and I think they would ring a bell, and then they would move on to their next task. That was the original idea of continuous integration, and in fact, that's what the team that I was working on in 1999, 2000, that's what we were doing. And lazy me, I didn't want to have to get up from my desk that I was working on. I didn't want to have to, I was like, why do I have to walk over to this other machine and do this? Couldn't it just detect that I was done, meaning I committed my changes, and do that for me?
So we just uncovered something right on this podcast, and that is the reason that Jenkins and these other popular continuous integration platforms exist today is because Paul Julius was lazy to get out of his chair. Is that right?
Exactly.
That's great.
Yep. So that was the original impetus was, look, this is totally automatable. Why should I have to get up and go do this? And so that's what we started doing. Now, the thing that happens on some teams is that they lose track of the fact that when that code goes over to that clean machine, it's supposed to go over to that clean machine and run and execute with everybody else's changes, any other changes that have come in, and make sure that everything works together. Because the longer we go without people's things working together, the more likely we are to encounter bugs that are hard to find and hard to fix. What we have seen over time is that even though people are automating the process of the build, automating the process of, does this code compile and test and work correctly? What they're failing to do is integrate everybody's changes together frequently. So some of the things we might see are, if I'm a developer on a project and I only commit my changes, let's say, once a day, or once every couple of days, or once a week, I commit all my changes. And in the meantime, I've got 5, 10, 100 other developers working, and they're doing roughly the same thing. There are long periods of time there that go by where we don't integrate our changes together. So that drift between my code and their code is likely to be rather large. And that's when we start to encounter bugs, we start to encounter merge conflicts, we start to encounter problems. And the whole idea with continuous integration was that we would do that more frequently. We wouldn't wait until an integration phase, which was popular in the 90s. There was a whole software process that had a phase in it named the integration phase. We said, look, this is painful, this integrating code together that has diverged from each other. That's painful. Instead of doing it at the very end and causing ourselves a lot of pain, we should do it more often. We should take a little bit of pain each day or each hour. And that was one of the key aspect, and I think that's what a big part of what James Shore was talking about is, that's what we need to be doing, is integrating our code together frequently, getting everybody's code together frequently, not having these long divergences. So that's what he was talking about, and we now have seen that, I think, go even further in some cases and become institutionalized, if you will, by things like the Git Flow model of software development branching, where not only am I working on my own private machine, writing my code, but then when I check in my code, it doesn't go into the same place that everybody else's code goes to. It goes into a separate branch within the version control repository. So when people like me, when us continuous integration purists see things like that, it's really an immediate revulsion, because it's the opposite of what we've been trying to do since at least the Extreme Programming White Book came out. And I think that it goes back even further than that with Microsoft and these other companies that were really building these million-line code bases every single day with everybody's changes in it. They were doing that back in the 90s. So for us to be delaying integration through separate branches or through, working for days at a time before we commit, that's really antithetical to, the entire purpose of continuous integration. So I think that's where Jim was coming from. Hopefully that, I know that also was a long-winded answer, but
that's great. Actually, great to hear the detail and the history behind this. And so, going back to that concept, and I think about you as a philosophy major. Why do you think, if that is a good idea, right? If the idea is to integrate frequently, and people accept that as a concept, but then from a behavior perspective, they're not integrating frequently. Maybe this is psychology, not philosophy. But I mean, what do you think is motivating people to not do that?
To me, what I think it is the avoidance of pain. We think that we want to avoid pain, and we know that, Paul, if you and I are working on a project and we're coding away for a little while, my code might be working great, and I know that, oh man, if I pull Paul's changes in, if I pull your changes in, that, I might have some merge conflicts.
It's going to break everything. Yeah,
it's going to break everything. So I don't want to do that. I don't want to do that right now. I don't want to deal with that right now. I want to just keep going, and I'll deal with that later. I don't feel like having that pain right now. The sort of interesting thing that we as humans forget, and we see this in not just in software development, but in all areas of life, like maintenance for our car. Once that little warning light comes on the car, we might think to ourselves, oh, I'll just, I'll get to that later. I'm busy. I'm running to the airport, or I'm running to the dentist, or whatever, and I'll deal with that later. But the longer we put it off, the more likely it is to be even more damaging to our vehicles. The same is true for us in terms of software development. The longer I put off integrating your changes, the more damage there is going to be, the more problems we're going to run into. But we aren't always able to step back and see that bigger picture, that longer term view. We sort of have this short term perspective on going about our work, which is, I'm right in the middle of something. I'm right in the middle of coding up this really interesting algorithm, and I don't want to have to deal with those changes. I'll do that at the end of the day, or I'll do that, I'll get this all coded up, and then I'll pull Paul Duvall's changes. But we're actually hurting ourselves by doing that. We end up costing ourselves more money by putting off our car repairs or our home maintenance repairs. In this case, we end up causing ourselves more pain by delaying it. That's why I love going back to that if something is painful, we should do it more often, not less often. It's literally a lot easier on us as human beings, on our psyche, on our pocketbooks, on our flow of work, if we take it a little bit at a time, take that pain a little bit at a time, rather than in one big chunk at some point in the future.
So you made a reference to Git Flow, and you talked about merge conflicts, things like that. And so have you seen places in which Git Flow can work with the continuous integration model?
So the way that I think about Git Flow is when we start a new feature, what we do is we create a branch within our Git repository, and we do our development work on that side branch. And then at some point, we will merge that branch back into some sort of mainline. I think one of the ideas is it gives us this opportunity to be able to isolate features within the code by its branch. And then if we want to, as we go along, if we're coming up to some sort of release date, for example, we could cherry pick which features we want to pull into the mainline and which ones we don't. And I think that there are some teams that, the way I would describe it is, they make that work. They put in the effort to be able to make that work. It ends up costing, most of the teams that I see, it ends up costing them a lot of effort in terms of continually merging branches back and forth between each other. So they're constantly having to keep their feature branch up to date with the main line, or they're constantly having to keep their feature branch up to date with other feature branches that are being developed. It becomes a bit of a logistical, I wouldn't call it a nightmare, because obviously they're making it work. It's legitimate logistical overhead that some companies find worthwhile to take on. The quick answer to your question is yes, I've seen some companies make that work at the added expense, having to manage these merges between each other. Now, is it continuous integration? Probably not. You can get it close because you can automate checking branches against each other. You can have an automated system check to see, do what if scenarios. If I merge this branch with this branch right now, would it compile and would it pass the tests? And would it, build whatever else is in the delivery pipeline? You can do that. But ultimately, we don't really know that everything's going to work together until we bring it together and then do a proper set of testing on it. And what I've seen more recently is companies hitting these roadblocks, hitting the realization that this type of delayed integration is still just delayed integration, and that even with all these maybe automated what if scenarios, or people or groups of people that are in charge of keeping these branches up to date, that it becomes something that just doesn't scale with their software development process, and that they end up trying to figure out other alternatives to it, which I'd be happy to talk about.
Yeah, definitely want to get into those. And so, some people that use the Git Flow model argue that it's because it gives them an opportunity to review the changes prior to going into the main line. And so have you seen organizations use it in that manner where they're doing it at the task level versus the feature level? So it goes, it gets committed as a task that they worked on for a couple of hours, whatever. Someone commits a pull request, someone reviews it, and then it gets into the main line. Have you seen that work well in a Git Flow model?
Yeah, I've definitely seen teams doing that. And in a way, what I've been referring to that as is the pre-commit code review, which is essentially as a gating factor to allowing a developer's code into the main line or into the software, into our Cathedral. We are going to have a pre-commit code review. And we could do that by having a separate branch that they're allowed to check into. And then the only way that branch gets merged is if somebody reviews the code and says it's worthy of being allowed in. Of course, this happens in the open source community a lot. Changes come in from outside parties, and they're usually people that that sort of monitor the open source project and try to keep it working as a whole. That's the way it has always worked for the cruise control open source project. There are those of us that have commit rights, and then there's a whole community of people out there who provide outside contributions. For me, within organizations, when they're doing this, it usually points to some sort of anti-pattern. It usually means that there's some lack of trust for what the developers are creating. And perhaps that's because, a developer is new to the project and maybe doesn't understand the architecture, doesn't understand the way that the team works together, doesn't understand the norms and standards that are acceptable. In which case, I think that for some period of time, having somebody review the code before it gets committed into the code base is a perfectly acceptable approach.
Well, so isn't that the idea of pairing? So how is this different in a situation in which you don't have pairing for whatever reason? And so there might be, and by the way, what I've seen happen most of the time is people say that they're going down this route with Git Flow, and then they end up down the route that you described before, which is, at the feature level, and basically the merge is, or the commits aren't happening to the main line as often as they wanted it to. Maybe that was their goal at first, and then it becomes every few days, once a week, whatever. So that said, though, the idea is to have someone review the code, right, beforehand, and that's the idea behind. Well, why don't you talk about pairing, because that's I know that's something near and dear to you.
Yeah, pair programming is one of those things that came out of the agile extreme programming movement that I really fell in love with and have been championing for a long time now. And the one of the aspects of pair programming. So anybody who hasn't heard of pair programming before, it's two people get together and they work together side by side or on the same code if they're remote. They work together on developing a piece of software and then getting it committed, and you get two people working on that code instead of one. And one of the aspects you get, one of the side effects you get from this is you get a continuous code review, because you have this person sitting right there telling you, oh, hey, you made a mistake there, or hey, you should probably follow this pattern that we use elsewhere in the code base. So for me, that's a much more efficient approach to the pre-commit code review. When we do pre-commit code reviews in the fashion we were talking about, which is as a gating mechanism to get into the mainline, usually in enterprise software development, we usually end up getting a backlog of code that needs to be reviewed by the few people that are allowed to review it. In the case of pair programming, we can actually work much more quickly because we've got two people working there together that are writing the code, and they can check it in basically as soon as they get to a point where, let's say, it passes their test-driven development tests that they're writing. They can check it into the main line. So for me, pair programming is a much better approach to getting that benefit that we want of pretty solid reviewed code going into our mainline.
So if you can't do pairing, then what?
One of the questions I always ask is, why can't you do pairing? So I don't know if we want to go down that path or not.
No, I'd love to get in that conversation. In fact, I mean, one of the things I think of you, I mean, you're the consultant's consultant, right? That question that you just asked, which is, instead of just accepting that, right? Let's go down that path a little bit. Why can't you do pairing? How do you go about that when you work with clients?
Yeah, I mean, usually people say, well, we're not allowed to pair, right? That's what I'll hear when I'm talking through different recommendations. Somebody in the group will say, well, we're not allowed to pair. That's usually how it'll come out. But if we phrase it as, well, we can't do pair programming, usually there are a few reasons. One is we tried it and it didn't work. Another one is we're not going to pay two people to do one person's work. Another one is we just don't have the time to slow down enough for pair programming, thinking that, I'm going to take this workforce that I have of, let's say, 50 developers, and now I'm going to get 25 developers worth of work out of them every day because I'm going to have people paired up. There have been some academic studies that have shown that pair programming is something like 30% more efficient. And there's certainly a number of anecdotal stories of teams that work in a healthy pair programming fashion are actually much more efficient than their counterparts, something like twice as efficient. And there are a lot of reasons for that. One is, if I'm working by myself in my cubicle programming away, it's easy for me to get distracted by work-related things like emails coming in that maybe could wait until later to get answered, or people coming by my desk and wanting to chat about one thing or another. Whereas when I'm pair programming, I tend not to check my email during the middle of my pair programming session. Or if I'm pair programming, people tend to just walk past my desk because they can see that I'm busy working on something with somebody else and they don't want to interrupt. It's also easy. I can't tell you the number of companies that I work at where, understandably so, people are checking in on lots of other things outside distractions like Facebook or even internal social media websites. There's this distraction factor that slows us down. And don't get me wrong, I'm a big fan of people taking breaks and keeping themselves in a nice workflow where they're getting a balance between really focusing on something and getting a bit of a mental break. And I like the Pomodoro style of going about that, if for anybody who hasn't heard of that. But
that's every 25 minutes or something like that, or
every 25 minutes you take a short break.
Yeah.
Yep.
Actually, it makes me think of another question related to that. And because you were talking about how with pairing, it's not 100% of the time pairing. The people are taking breaks and things like that. And when it comes to the coding part, one of the books I recently read was a book by Cal Newport called Deep Work. Basically, it's about, getting into flow. And I think about programming as, that kind of activity where you can get in that flow. He actually makes arguments for people working together and still getting in that flow. But what's your response to, programming is a solitary activity, and when you can get into that flow and not be, effectively having another person that's distracting you, essentially. Have you found where times, maybe they're pairing most of the time, but times in which they are able to focus on, one particular thing they want to solve?
Yeah, I mean, for me, what I usually like to encourage teams to try is I like to encourage them to start out by trying pair programming 50% of the time. So that means, let's say half their day, they're going to work together on something with somebody else, pair programming, and then the other half of the day, they're going to do the solitary activity. And what I find is that for me and several other people that have gone through this sort of experiment, this 50-50 experiment with me, is that they get to the point where they would rather be working together with somebody else, even on the things that they would have rather done solitarily. There are some activities that are just, experimental in fashion, or you're investigating, you're spiking something out, you're trying something new, and you don't quite know how it's going to go. So you feel like, I need the latitude to just be able to kind of bounce around, and it's not going to be something that I'm going to do in lockstep fashion the way I would want to do if I were pair programming with somebody. But what I find is that by having the other person there participating in that process with me, it's actually much more efficient, because it's sort of like, there's this technique called rubber ducking. Have you heard of that, Paul?
Yeah, I think Dave Thomas talked about that. Is that right?
Yeah, that sounds right. Where you're working on something and you feel like you're stumped, and then before you get up and go and ask, let's say, the expert how to solve the problem, you turn to the rubber duck, the stuffed animal, the inanimate object in your cubicle or at your desk, and explain the problem to the rubber duck. And just by articulating it, just by saying it out loud, it actually helps your brain work through what the solution probably is. And I find that is what I run into a lot of the times, even when I'm working on these things that I would naturally want to do solitarily. So after doing this 50-50 experiment, where we try it for half a day at a time, a lot of people gravitate to they would rather be pair programming 90% of the time or 100% of the time. And I think it speaks to that once we overcome that initial hurdle, that we actually are able to find these ways to work much better together by leveraging two minds instead of one. So that's the way I think about it. But I've sort of pulled back from maybe in 2008, 2009, I would have been a lot more hardlined about, look, we should be pair programming 100% of the time, to encouraging people to experiment. And I just want to throw in there another thing that I've been really excited about. And this was another thing that as a CTO, I was able to green light and actually worked really great, was mob programming. So I don't know if you've had a chance to hear about mob programming.
I have heard about it, but yeah, maybe if you can tell the listeners about that.
Yeah, so mob programming is where you take the entire team of people, and in this case it was a 5-person team, and they would all work together on the programming task at hand. They would get into a room, and then later we ended up developing a workspace, just a natural workspace for them, and they have, of course, a big monitor, and they trade off who's at the keyboard. And whoever's at the keyboard, there's only one keyboard, one mouse. Whoever's at the keyboard, they're allowed to type and move around within the programming environment. But all the ideas for what needs to be typed, or what the solution is supposed to come from the other people in the mob, the other people in the group. So if let's say you're working on you're trying to program up some database interaction code, and you really understand how the database API works, you would be not the one at the keyboard. You would be the one off to the side, and somebody else would be at the keyboard who maybe doesn't understand it as well. And you would be explaining to them what to type. And in doing so and explaining to them what to type, you're explaining, of course, to everybody else in the mob. And what you get is you get this team of people, this 5-person team of people that are all becoming equally knowledgeable, equally invested in, have an equal understanding of the code, the application that they're creating. And in the end, there's some neat side effects, like they're all equally able to support it if something goes wrong. So going back to something I mentioned earlier with part of the whole continuous delivery DevOps model is being able to provide operational support for those things which we create. Using this mob programming approach, it really created this team of people that were all equally able to jump in and help solve problems whenever there was a production issue. The team loved it. They preferred it to standard pair programming, and they would do this for about 6 hours a day. They would mob program. And then I also found that the other 2 hours a day, they would frequently be just doing traditional pair programming. And they were more effective, more efficient working as a mob on their backlog of stories than they were individually.
Interesting. So people talk about full stack developers, and you'll have a small team that's full of full stack developers, but effectively you can actually create silos in those small teams as well from a understanding of the architecture feature perspective. And you're saying mob programming, in your experience, has helped have effectively a full stack team across all the individuals and try to reduce the silos that can occur within the teams based on their functions.
Yep, exactly. That was one of the anti-patterns that we were trying to combat with initially pair programming, which does help that if you're doing pair programming and you're rotating pairs within the team, frequently, like let's say daily. That helps to eliminate these silos of functional areas, architectural areas. But even more so with mob programming, you end up with no real silos within the team because everybody is working equally together on everything that the team is developing and creating for their application. So it's extremely, extremely powerful. And again, we started out with a short experiment to see how it would go. And I think that one of the things that we software developers can do is be applying sort of a scientific approach where we do these short experiments and measure outcomes and make decisions based on those outcomes. And this is one of those times where we measured outcomes and we were happy with the results. As a armchair scientist, I would be willing to accept that a different group of 5 people mob programming in similar fashion might not have the same outcomes, and I would accept those results. But I think all of these things, pair programming, pre-commit check-ins, if you think it's going to solve a problem, it's okay to try. It's okay to experiment with it, but then measure the outcomes and be willing to accept when evidence goes contrary to your hypothesis.
Right. So when we were talking about before about continuous integration and Git Flow and the merge conflicts and things like that, you mentioned some of the patterns that can help prevent that. Maybe if you can talk about those patterns a little bit.
Yeah, so some of the patterns that you can use to avoid having to do things like feature branches are one thing that we used on a team that I was working on was championed by Paul Hammett, who you mentioned earlier. Paul Hammett champions branch by abstraction, and I think he's even started a website around that as an architectural notion where you use abstractions within the code base to provide branches of code that would be executed under different circumstances. And that's akin to what other people refer to as feature flags, where you have some sort of flag that you can use to turn on or off a feature within an application, depending on whether or not you want that feature to be active at any given time. Now, the thing I like about both of these is that it keeps the code for the features, it keeps the code active and live in the mainline code base, meaning it's getting compiled and ideally also getting tested at every step along the way. So there's never a point in time where the feature is off on some side branch and potentially getting merge conflicts or just other types of logical conflicts built up in it. Instead, it's right there in the main line, getting tested and compiled at every single commit in a continuous integration framework without having to jump through all these hoops that we have to jump through when we have these separate branches. So that's what I tend to recommend to applications, architects, software developers, is use those sorts of approaches instead of having these separate branches of code.
And so in some ways you're creating separate branches of code with the toggles, right? But within the main line. And so I think the key thing is that, like you said before, is that you are testing out all those scenarios. It's still within the same code base. It's not as bad as having a branch, but effectively they are little branches, and they're definitely little branches if people aren't running tests against all those scenarios with the flags on and off and things like that every time someone commits code to the version control system.
Yeah, I mean, they're branches in the code sense of branch, right? They're a code branch. They are not a version control branch. They're not a branch in Git or Subversion or Perforce or whatever our version control system is.
Yeah, so therefore you don't have to go through all the ceremony or whatever through that. If it's not being tested, you're going to have issues.
Yeah, if it's not it needs to be tested. All of our code needs to be tested, and we need to ensure that it continues to work as the system around it is continually changing. Things are continually being added and taken away from the code base, and we need to have tests there to protect us from the side effects that any of those changes might have. And that's one of those sort of things that creep into the code base that we don't realize just by relying on only a compiler. For example, a compiler doesn't always find these side effects that creep in when the system continually evolves, and these side branches of code that expect a certain sort of behavior from other parts of the system. If that behavior changes, we need to be made aware essentially as soon as possible when our code branch breaks as a result.
Have you worked with customers that are employing things like synthetic tests, or because a lot of what we've talked about is before it gets to production and all the testing and checks and things like that prior to going to production. What we've been seeing a lot of recently is that because these changes are being delivered to production all the time, you also need a whole set of production level tests and bringing the insight back into the development workflow. Have you been seeing that?
Yeah, we've actually on one of the big applications that I was responsible for as the CTO, we ended up migrating a huge portion of the testing, runtime testing, because we got to the point where the testing that we were running, continuous integration, continuous delivery time, became more and more brittle and harder to maintain, harder to keep up with. So what we ended up doing is we ended up moving to a large portion of that being runtime monitoring and phasing the application into production based on traffic performance. So is that the type of synthetic testing that you're thinking of?
Yeah, it's effectively using monitoring as well, and you think about behavior-driven monitoring type stuff, and yeah.
Yeah, so I'm a huge fan, and I think it works great for a wide array of applications, especially web-based applications where we have enough traffic coming in to start to see patterns developing. In the case I'm referring to, if any sort of problem was introduced into the system, you would see a noticeable change in the way that the traffic behaved, the way that the messages were flowing through the application. You would see that within 20 seconds of the application being released to production. And again, we were only running this on a percentage of traffic, but it was an immediate red flag. Of course, then you have all the the checks and balances in place to be able to phase that back out of traffic so that it doesn't continue to interfere. But then you use that feedback that you got to figure out what the problem was. For applications that have that kind of traffic coming in, that huge amount of volume coming in, I think that works really well and pays off a lot more than what we would traditionally do with some of the more upfront automated testing, just because of the nature of maintaining all that automated testing.
So you and I'm pretty sure you were at this. This was back in 2008 at SD West, and we had gotten together with about 40 people and people that were interested in advocating continuous integration throughout the development community. And I remember, and you might remember his last name, but it was, I believe his first name was Ben. Andy Glover, our mutual colleague and friend, wrote about this. I ended up writing about this a few years ago as well. But basically, he stood up during this. It was an open spaces kind of event that we sort of set up, about, like I said, 40 people or so. And he stood up and said that continuous integration is a hack. And then he went on to say that, as he explained himself, he was mentioning that we should be able to, and I might be modifying some of this based on my 10 years ago now, but basically what I took from it was that if we're in our IDE and we're making some changes, we shouldn't have to then go through this whole separate process. And at the time, it might take a long time, especially when you start to incorporate, the continuous delivery kind of concept into it. It might take several hours before it gets to production, for example. But his idea was, we should just be focusing on the coding, and then everything else should just be happening, and we should be able to get that feedback effectively in real time as we're developing our software. And so I say all that to say to you, do you remember that? But secondly, what do you see as the future of these types of software delivery practices? Where do you think it's going? What's interesting and exciting to you?
Yeah, I do vaguely remember that, and I think that notion has come up often, and that what I really want to do as a leader of teams of developers, or as a manager of organizations doing software development, or as a consultant trying to help organizations be more effective, is I want to keep people focused on what is interesting about software development, and some of these things that we've been talking about are drudgery. Merging branches together is drudgery. And, I wish I had all of the hours that I've spent watching continuous integration systems attempt to build, test, and deploy software. That's a lot of drudgery. And what I'd much rather have people do is focus on the interesting things. And I love that idea of, look, I want to just be in my IDE. I just want to be in whatever my development environment is, coding away and being able to essentially have it. What I would like is, as soon as I click, let's say, save, or I don't even want to go so far as to have to call it commit. I'd like to be able to see that get checked out, in the sense that, something checks to see whether it works. And then as long as it works, it goes out to production and gets in front of my customers and starts making money for me. The idea being that every change I'm making to the system is ideally helping me make more money, helping the customer be that much more delighted with whatever the software is that we're producing. I was talking with a friend of ours, I think Julius Shaw, and he and I have worked together for years, and one of the things that he was doing was he was setting up his continuous integration environment to operate in what he was calling ludicrous mode. I love this ludicrous mode idea, and the idea is that essentially every time he clicks save, or every time he saves, that the system runs the tests, and as long as the tests are green, it commits the code, and then that ends up going out to production. And what he found was that he ended up having something like 200 production releases of this code every hour, and hence the name ludicrous mode. you can imagine the way that changes the way that we work, where we're working in these very small increments. We know that, oh, when I click save, something's going to happen in the background. Maybe the test will fail, which is okay. That just means it's not going to go to production. So that might be the case if I'm doing a test-driven development or test-first approach. I'll have a unit test there that's gonna fail until I write enough code to make it pass. In that case, that's okay. It's just gonna keep failing, and then eventually it's gonna pass and go out to production. It also makes me think a lot more about how I do that test-first development. It makes me want to make sure that I have the right kinds of tests in place, or I write the right kind of tests so that I can get my code out to production quickly. And the way that I see things evolving is just this progression of what we're already seeing. When we started doing continuous integration in 2001, the idea of doing compilation and unit tests and automated functional tests and all of that, all within, an hour, would have seemed ludicrous. Today, for many applications, that seems very doable. In fact, there are lots of applications that I work on that we have architected the application in such a way, and we've written the tests in such a way that there are many releases to production going on per hour, 3, 4, 5, 6 releases to production every single hour, and it's a direct line from the developer making that change, introducing that new feature, fixing that bug. It's a direct line from there to production with very little interaction in most cases, and let's say 90% of the cases. And I think that the way I like to think about this is just even more so where people like you and me and the other kinds of people that we work with, we're essentially trying to automate all of these necessities to get from the developer doing the interesting bit, the software creator doing the interesting bit, to it getting in front of the customer and making money or delighting the customer. And I think that we're going to see more and more of that, or from the software creator's perspective, they'll see even less and less of that. I'm hoping that all of this conversation that we had, let's say, around Git Flow and around branching and merging and stuff, I'd like to see that start to fade away as it becomes almost something of the past, an artifact of, well, we had to use branches at that point in time because we just didn't have the CPU bandwidth to be able to keep up with the types of builds and everything, or we just didn't have the right type of architectural patterns in place to be able to allow us to create applications without branching. I would love to see version control as a sort of heated point of discussion fade away to the point where yes, it's there, and yes, we can always go back, and yes, we can always look at what we did or where we were at a certain point in time, but that it's more of just a part of the environment, in the same way that a lot of IDEs do that today. We can go back in a lot of IDEs, we can bring it up and see, what were we doing a minute ago or 5 minutes ago or a day and a half ago?
Yeah, I think of it as like Google Docs, for example, right? It has an automatic version history, but you don't know. I mean, you only care about it when you need it. And so, yeah, I'm hoping all this discussion that we have here around continuous integration, continuous delivery, all these things, 10 years from now are quaint. It's like, oh, isn't that cute that you used to talk about such things? Of course, it's going to be a different problem at that time, but that we spent so much time, the way that we look back at mainframes and, you had to run down to get your print job or something like that. A lot of people laugh at that now, right? That in 10 years that all this stuff that we're talking about now is it's transparent. Yes, it still happens, and yes, software gets delivered out to production, but it's really systems that are creating these things, and not, the developer needs to know, like you said before, They don't have to say, I'm committing the code now. The commits are really basically happening, and they're focusing on the business logic.
Yeah, our ultimate goal is to help people, help humans, focus on and do what humans do best. This creative aspect of creating software that is helping make the world a better place.
For the latest DevOps best practices on AWS, follow our blog at www.stelligent.com/blog.